My name's Ian Somerville. I'm the Professor of Software Engineering at St Andrews University, and my group has been working with companies, primarily in the Aberdeen area in fact, looking at transitioning their operations to the cloud. And I'm going to be talking a little bit about that and about the general issues of cloud computing. I'm going to talk about moving to the cloud and the issues of companies migrating to the cloud. When we're talking about the cloud, what we need to understand is that basically we have, every 15 years or so, seen a kind of technological revolution. So we started with mainframes back in the 60s, and then in the 70s we had mini computers. Okay, I think there's a DEC PP8. Then we got personal computers in the 1980s. They got a bit better than from the original prototypes. And then in the 1990s, we had the web. The first web browser, Mosaic browser, I think was 1993 or 94. But basically, every 15 years or so, we have this technological switch. We have a new paradigm for computing. And what we have now is another paradigm, cloud computing. We're entering into another paradigm shift from computing. And this will have a very significant effect on the way in which we use and build IT systems. Let me take you back to the Industrial Revolution. Cotton mills, big machines, power engines that drove the machinery. Okay? The Industrial Revolution was fueled by steam. Every cotton mill had its own steam engine, or sometimes water engine, so that and via a very complex system of pulleys and belts, they drove the various spinning and weaving and whatever other kind of machines you do with cotton wefts and weaves and so on and so forth. Then, around about the beginning of last century, it all went away. Why did that happen? It happened because of electricity. It became more effective to build electric motors, to convey build electric motors, to install one of these with each machine, and to generate the electricity centrally and deliver that over a grid network, so that no longer did factories have their own machines, they simply bought power externally. So that was a big switch. It was a switch from everywhere having their own electricity generation to buying that centrally. You see the analogy. This is quite a good book. I'd recommend this book if you want to it's quite readable. It's all about the notion of how cloud computing is the analogous switch in computing. That no longer will organizations have their own computing, but rather computing will be supplied centrally in large data centers operated by conglomerates, and it will be delivered over the internet. So cloud computing essentially relies on this paradigm shift, on the shift from in-house to externally provided computing, with the computing services delivered over the internet. And of course, over that, this all started not much more than 4 or 5 years ago, but since then we've had an explosion of cloud services. From the big players, Microsoft and Google, to a bookshop, Amazon Cloud Services. They reckon they'll make more from their cloud services than they will from their retailing operations in a few years' time. More specialist providers like Rackspace, and then of course companies like Salesforce, who are delivering services rather than computing, and So various local companies like Flexient and IOMart, who are Scottish cloud companies. So we've seen this model of centrally available services delivered over the internet being adopted very quickly. And of course, businesses are looking at this and saying, well, should I switch? Well, cloud computing, of course, means different things to different people. This is essentially a cloud computing stack, and I'll not bother about the bottom layers of the stack. I actually use this slide in an introductory lecture I give in cloud computing. And the hardest bit to explain is this bottom one in virtualization. Actually explaining virtualization to people who don't know anything about it is really very, very hard. So I'm not going to attempt to do that here. I'm going to start here and look upwards on the stack. And we normally talk about 3 levels of cloud computing, so-called infrastructure as a service, platform as a service, this level here, and software as a service. Infrastructure as a service is actually, in some ways, the easiest to understand, and it's had, in financial terms, the greatest impact. An infrastructure as a service, essentially you have a cloud provider who delivers you a bunch of machines. These are typically virtual machines of various sizes and configurations available in their data center, and you buy the computing and storage services that you require. Instead of running your own servers, your own compute servers, storage servers, or whatever, you access these remotely. It's a simple concept. Amazon have built a very successful business running this. Platform as a service is a kind of level up from this. Platform as a service provides you with a set of APIs that let you access a set of machines and program your applications to use that set of machines. Infrastructure as a service is just like having your own server, and you do what you like with, more or less what you like with it. Okay? You don't get any help in actually using the cloud or in building any specialist cloud-based applications. Platform as a service gives you that help. It provides you with a set of APIs which then allow you to take advantage of the cloud. So, for example, unlimited storage, or so-called elasticity, where you can actually, as the demand increases, you can increase the computing power required. So there are various levels. Amazon are actually moving towards that level at platform as a service. Google, but particularly Microsoft with your Azure platform, are very much dealing in this platform as a service space. And the top level is the one which we're all familiar with. It's software as a service, where you actually, instead of running an application on your local computer, you access, your local computer is simply a client, and you access a service through a web browser. Most people have used things like Google Docs. Almost everyone's used Gmail. Professionally, there's a company called Salesforce, which has built a very large business, providing business services over the internet. You get Mint, who does financial services, and various commercial image editing services as well. So, software as a service is an area where there's probably the greatest economic potential. But it's actually proven to be quite difficult for companies to make much money at this area, simply because people like Google give it away. Because they don't want your money, they want your identity. Okay, so because once they have your identity, they can actually make more money than you would be willing to pay for their docs or mail or whatever. So this has actually meant it's very difficult for companies to make a lot of money at software as a service. And the economic model for this is still developing. Although, to be fair, companies like Salesforce have been very successful from a business level, but at a consumer level, it hasn't really worked. So what I'm going to talk about is moving to the cloud. I'll talk about cost, because you've probably heard that it's cheaper to run things on the cloud. I'll talk about the benefits, which in my opinion are much more important than the cost savings. And I'll talk about the risks. So the costs. This is Amazon's costs for their, it happens to be for US East, which seems to be their default when you come up on their cost pages. Basically, this is how much you pay per hour for a particular server. Okay, so if you want a small server, it's not 6 cents per hour. If you want an extra large one, it's 48 cents per hour. Probably you have no idea what kind of server you need. And Amazon made quite a lot of money by people ordering bigger servers than they really need, because nobody really wants to say my application is very small. They all want to say this is significant, but generally speaking, this is quite a hard model to use. And one of the things I'll talk about is how we're trying to help people use this costing model to get a better picture of how costs will develop using this model. So you've got the costs, and this saves you money. Well, maybe it saves you money. It saves you buying servers, air conditioning, switches, storage. You don't have to buy any of these things. You've simply got the cost per hour, cost per gigabyte or whatever, which you buy from Amazon. As you need it, when you need it, the amount you need. You don't have to buy a 500 gigabyte disk if you only need 3 gigabytes. Does that deliver cost savings? Well, if you believe the hype, you'll believe it does. Most of the analysis that we have done suggests that the cost savings for the majority of businesses who do not provide consumer internet services are not significant. There are areas where that's not necessarily true, but essentially the reason why the savings are not that significant is that what the cloud gives you the opportunity to do is to move costs from fixed costs, providing an IT infrastructure, say, to variable costs, providing only what you need when you need it. But most businesses can't actually move fixed costs to variable costs and so reduce their fixed costs. There are fixed costs which they necessarily have to have. And so therefore, unless you can do things like shut down your whole IT systems, and not many people can do that, the savings are not that great. But the amount you move your fixed costs to variable costs are not huge. And Amazon's actually pretty expensive. If you buy a server from Amazon and run it for 3 years, it costs you about 2.5 times it would cost them to buy that server and run it in your own computer room. So the savings that you get if you have a predictable load on your computing systems are really not that great. In fact, they can be the opposite. They can cost you more. However, I think that's unimportant, because what we get from the cloud is something completely different. We get an opportunity to do business in a different way. Everybody's heard of this notion of bring your own device, people using their own phones and computers for business purposes. But essentially, what we have with the cloud is the ability to support heterogeneity. It is, or it was the case, probably still is in many businesses, that they're very homogeneous environments. Everybody has the same computer, the same operating system, etc., etc. And that's fine for people who that's good for. If it's not the right computer, for others, it's a pain. The cloud gives you this opportunity to support a whole range of devices, from smartphones through to laptops and desktops, and to seamlessly interchange information across these. So that actually is a key advantage of the cloud. You can do things differently. It makes it much easier to think about globalization. When your data is on the cloud and your customer is at the other side of the world, they can get access to that just as easily as you can. It allows you to have a distributed workforce. It opens up areas of possibility and collaboration. What we see with things like Google Docs is collaborative document editing. Not something that I've ever found that useful, but it's certainly put forward as a great benefit. And I think it, more importantly, it means we can rethink how we do work. The key problem that we face in computing at the moment is the shortage of qualified people. And what we have to do is get rid of all the barriers that do exist to allow people who are qualified to contribute and get into the workforce. And a really important segment of the population is mums with kids. So cloud computing makes it much easier for them to work flexibly, to work from home. And that's a great opportunity, I think, for us to actually expand our workforce and to take advantage of an underutilized asset in the workforce. So this ability to work across the world, to change the way we work, is, I think, a key benefit from the cloud. And the other benefit, of course, is you can build resilient systems. Most organizations, if they were to be hit by a serious weather event, would have problems. Providing resilience, if you have an in-house data center, in-house system, is extremely expensive. Basically, you have the notion of replicated data centers, disaster recovery things, but a very significant businesses in the US hit by Hurricane Sandy simply went out of business because they could not recover their IT in a reasonable amount of time. They're dependent on their IT systems. They could not get these back up and running in a short time. And in reality, the capabilities to provide that data recovery service probably didn't exist. What we can do with the cloud is build a much more resilient service. We can actually build systems that will have a very high probability of 24/7 operation. We can replicate services across the world. We can actually relatively easily have systems running in US East, which is Amazon's service, and in Dublin, which is where one of their other data centers are, so that in the event of bad weather in one, we seamlessly switch to another. So resilience, this ability to build systems at virtually no cost. Because what you've got to remember is that these systems, your backup systems are running there, they are provisioned on demand. When you need them, they come up in a few seconds, but they're not costing you anything when you don't need them. So communication and resilience are, to my mind, the benefits from the cloud, not the cost savings. And if you're a consumer-facing business, you get this tremendous ability to provision servers quickly. Some of you may have seen a company called Animoto, Animoto actually produce an application which is is clever when you use it once and then it becomes a little bit dull. But essentially, you give it a set of photographs and you say what kind of music you like, and it produces a short video, which is actually your photos animated to the music. And it's quite fun. And Animoto, I don't know when it started, but it went along for a while at a very low level of utilization, somewhere under 100 servers. And then somehow it went viral on Facebook. So the demand on Animoto increased in 3.5 days from 50 to 3,500 servers. To actually start, because what they're doing is quite computationally intensive. So the situation there is that they could not have provided that without the cloud. They could not have provided that without the ability to quickly buy computing time when they need it, so-called provisioning servers. And as I say, if you have a consumer-facing business, this is the kind of thing that can happen. Most businesses don't have that requirement for elasticity because they have quite predictable demands. So they don't have to worry too much about that. But there are others that are different. So the benefits are cost, maybe. Collaboration, resilience, and elasticity. The downside, of course, are the risks, the bottom half of the cloud. And like everything else, the cloud has its own set of risks. I'll cover that up. When things go wrong, they affect a lot of people. Amazon went out last Christmas, and Netflix, the film service which runs on their servers in the US East, apparently couldn't deliver people who wanted an alternative to whatever the BBC and ITV were offering at Christmas. So because they serve such a large constituency, in the same way as if a power station fails, it's a serious problem for an electricity company. If you have problems that affect a data center, it's a serious problem for the users of that data center. Especially if they haven't designed their systems to be resilient. And resilient system design is something that's not necessarily always practiced. So you have the issue of serious effects when they go wrong, but to be fair, they don't go wrong very often. So you have to accept it might happen occasionally. The thing that everybody knows about, and the thing that's talked about most, is the issues of security and compliance. And these were said to be the barriers. I don't know when this slide was produced, but basically what we have, 90% of people are concerned about security and compliance in the cloud. There's an awful lot of talk in this area. I'm not totally convinced that much of it is that informed. There is a belief that security-aware firms don't use the cloud. Actually, the opposite seems to be true. It's only people who don't know much about security who are frightened of the cloud. And if you think about it, that makes a lot of sense. If you're a 30-person company, you cannot afford to employ a security specialist. You certainly can't afford to employ a world-class security specialist who's probably getting paid $150,000 a year. If you're Amazon or Google, you can. You can afford the best technology, the best people to preserve the security of your system. You can focus on that if you're a cloud provider. So the reality is that the security, in my opinion, of the cloud, in terms of the classic notions of security and denial of service, and information assurance and confidentiality, is almost certainly better than the security of the most in-house systems. The risks that come from the cloud are not or the security risks that come from the cloud rather, are not the risks at the cloud providers. They're the risks of what happens with a business model which is facilitated by the cloud. So people are using laptops at airports. Okay? So using Wi-Fi networks that they don't know anything about, and simply finding a free network or finding a network and connecting to that with no idea of who might be connecting to that. Everybody here must know somebody who's lost a laptop at an airport or a station or a train or something like that. That's your security risk. And if you like, that's a security risk of the cloud, because that kind of stuff, that kind of work is perhaps not possible without the cloud. But that's the biggest security risk, far bigger than problems that you have with the cloud providers. Compliance. Compliance, I like to look at it at two levels. It's the compliance with the rules and regulations that are set by customers, and the compliance with the rules and regulations that are set by the regulators or by law. And we have this notion of a service level agreement to the service level agreement to try and establish what is expected from the cloud, if you're a cloud provider and a customer, or if you're delivering services, what you're expected to deliver to the customer. And theoretically, there's redress if the provider does not satisfy their service level agreement. We don't know how to write service level agreements, we don't know how to measure service, and we don't know what to do if we don't meet them. Essentially, Amazon give you a little bit of money back. Okay? They say, well, you didn't spend your £6 an hour for 20 hours or whatever, so we will give you back $6. Whatever, they give you back some money, right? Irrelevant if you've lost business for that amount of time. They don't compensate you for loss of business, because they can't measure it. Who can? So one of the key issues in compliance, or at the customer provider level, is how do we construct these service level agreements, and how do we actually police and manage these agreements? And the truth is, currently we have no idea. At another level, we have the national rules and regulations, national, international rules and regulations. Lots of these apply. Things like Data Protection Act, what do you do with personal data? The Sarbanes-Oxley Act, which is a US act about accounting. Rules on data retention, tax rules, etc., etc. Lots of things which affect the ways in which businesses have done. And with ambiguous consequences for the cloud. I see compliance as a much greater barrier to moving to the cloud than security, simply because most lawyers don't understand the cloud. I hope, I just found some logos for Aberdeen lawyers here. I really hope I'm not maligning them, but the probability is that they're very good lawyers, but they simply don't understand the cloud. And they're lawyers in those circumstances always default to the most conservative option. Don't do it. Which, which is kind of fair enough. So the problem there is that we have a complex legal environment, a legal and regulatory environment in which we're trying to run our systems. And nobody, or very few people, really understand what happens when we move things to the cloud. There are very real problems. In general, I think the problems are probably exaggerated. if you go with big providers such as Amazon. I mean, there's an obvious real problem of what happens if you have to retain your data and your cloud provider goes out of business. How do you get your data back? If you use the larger providers, I think these are not significant problems. But it's a very real concern about moving to the cloud, and a very understandable concern. Systems administrators. We all love them. We all know them, we love them. And one of the problems, what's trumpeted as an advantage of moving to the cloud is that you save money as systems administrators. You don't have to hire as many people. Okay, that's what happened to the government when it decided to get rid of all its IT experts? They ended up buying IT expertise from the large consultancies, paying rather more than they would have paid their own IT experts, and getting biased advice. If we get rid of our in-house IT staff, who's going to help us question the advice we get from the cloud providers? Do you trust them? Surely not. It's like trying to trust an electricity company, an energy company, to do fair pricing. So we actually need to keep, in my opinion, we take a serious risk if we actually get rid of our sysadmins. I know they can be very irritating at times, but they do know a lot, and they can be very helpful. And the other risk, which was an interesting one, which came up with a couple of businesses in Aberdeen, was a travel agent problem. Nobody goes to travel agents now. Very few people go to travel agents now. Travel agents have been the ones in the middle. But if your job is to provide IT services to customers, and then you outsource these IT services to the cloud, maybe the customers will come along and say, well, I can just do that myself. I don't need the people in the middle. And that was a very real concern in these companies, that in fact, if they moved to the cloud, their customers would move with them and then get rid of them. So that's an issue you have to think about. Are you a travel agent? Is your business built on a travel agent model? If it is, who knows? Okay, so some of the work we've been doing is actually trying to build a tool, a software tool, that helps us make some of these decisions about moving to the cloud, on costs, on pricing, on services. And this has led to a spin-out company from the work we've been doing called Plan for Cloud. And basically what we have is a simulation system, a price simulation system. So you can actually say, this is what I think I want, and it will tell you how much it will cost from the different providers. And one of the interesting things about that is that Amazon have got lots of data centers around the world, and you would think they would all cost the same, but they don't. They're sometimes quite radically different. So choosing a data center, which if it's thousands of miles away, probably doesn't make much difference in terms of latency. Choosing one in Singapore rather than Tokyo might save you quite a lot of money. So what we were able to do in this simulation system is actually take a set of requirements for a cloud-based system and to run that against a number of clouds and to produce a report telling you how much that is going to cost for each of these systems. So you describe your system, and that runs the simulation, and you then choose. You can then actually choose the cloud you want, and it goes ahead and establishes a contract with them. It's better than the systems that are produced by each of the providers because it makes it much easier to do cloud comparisons. You can go, each cloud provider gives you the same system in some respects, Although again, do you trust their costing systems because they're not impartial? But the key advantage here is you get many providers. What's particularly different about our system is it allows for consumer-facing businesses who have got elastic demands to do the comparison, to do price computations. So at Christmas, for example, we know that retail businesses tend to have a spike in demand, so they maybe need more computing power. So Plan for Cloud includes the ability to set up growth patterns, how things will change, either regularly, because you know you have increasing demand, or in spikes, and it takes that into account in calculating your computing costs. And this is the only system that exists that will allow you to do this kind of comparison. And it ends up with a report that tells you how much your annual costs will be for these different types of system. Okay, so far so good. We can work out how much our infrastructure is going to cost with a reasonable degree of accuracy. These are within 5 to 10% of accuracy as far as we can see. What if you're a service provider and you want to know, how much can I make from this? How much do I charge for my service? I've got a software product. I know I can sell this for so many pounds or dollars, but if I want to turn that into a service, how should I charge my service? What will my revenue look like? So we've been working with colleagues at RGU here on a system to try and do some of this revenue prediction as well as the cost estimation of the system. So what I decided to do today is take you through an example, and I set up a service called an SE video service because I've been making videos recently, and I set out to do the costing. And this is why my talk isn't what I thought it was going to be, because I got to the stage of setting up the service and it stopped working. Nothing worked. I was working from home. I called our sysadmin folks and said, is there anything you can do? And he said, Derek's not here. He's the only one who knows anything about the cloud. We don't want to touch it. So my talk on how to set up a revenue prediction system was somewhat curtailed. Basically, what we do is we use a very similar model to the cloud costing system, where we actually let you input a range of costs for potential costs for services, and it calculates the revenue that can accrue from these. We also have a cost model with that, and we base this on the notion of user classes. So that if we have what we call a heavy, if 60% of our customers are heavy usage, that is, they use them a lot, we assume we'll get a certain amount of revenue from them. If they're light usage, we get a different amount of revenue, and we can calculate the profit that will accrue, and we have some spikes, which are probably to do with annual events from that. However, saying any more about this system, I'm afraid we'll have to wait for another day. The problems of using the cloud. Okay, in summary then. We have the idea. Large-scale data centers, analogous to power stations, delivering computing services over the internet. Think of the cloud as that. It's the next paradigm from mainframes, mini computers, personal computers, and web browsers. Is it the same as electricity and steam engines? I don't think it is. I don't think that Carr is right when he talks about the big switch. Because if we look over history, and I'm old enough to have seen all of these, what we have is a situation where a new technology comes along, but the old one doesn't go away. We've still got mainframes. IBM still have a mainframe business, which is reasonably successful. We've still got mini computers. We call them servers now, but essentially they're mini computers. We know we've still got PCs, laptops, except we've got lots more of them now, and some of them are very small. And many of us still use web browsers and desktops or whatever. So what we've seen in computing technologies is new technologies being added and facilitating new things, new ways of doing business, and the cloud is going to do the same. But it's not, in my opinion, it will not necessarily replace these old technologies. I think if you think about the, certainly in the next 10 years, the quality of our internet service is nothing like good enough to allow us to store large volumes of data on the cloud and access it in real time. If you try and upload on an ADSL line this presentation, okay, which is about 15 megabytes, it takes several minutes. Okay, so that's on a consumer line. Okay, you can't run your computing systems on something with that degree of latency. So until we have completely different kind of broadband services, which is an order of magnitude greater than we have at the moment, cloud is not going to replace our personal computers. But even if it did, would you trust it? I wouldn't. I would want to keep my data to myself, as well as having it on the cloud. And that's the big difference between electricity and computing. In electricity, you don't have to give anything to the electrical companies, to the electricity companies, except, it seems, increasingly large amounts of money. In computing, you have to give them your data. Your data is precious and valuable. And that's why I believe that the analogy breaks down, and that we will always want to retain personal control of our data as well as using it on the cloud. So migrating things to the cloud has huge benefits. But transitioning a whole computing model to the cloud, in my view, the risks currently outweigh these benefits. Thank you.
Easy is it to change your cloud provider and move all your data?
That depends on your data.
Okay.
And how much of it you've got.
If you've a big business or medium-sized business with 2 years worth of data, for example.
It's at one level it's quite easy in the sense that you can say move from Amazon to Azure, and there's no particular technical problems in doing that, but it takes a lot of time, because shifting very large volumes of data over the internet, even at 100 megabits seconds, takes quite a long time. So I think what we find is that people don't move cloud providers very often. It's a bit like banks. People don't move banks very often. So I suspect cloud providers are much the same. But it's not technically difficult to, if you're running an infrastructure, if it's infrastructure as a service, if you're buying infrastructure, that's not technically difficult. You can buy a server from Rackspace, you can buy a server from Amazon, and you can, they call them different things, but they're basically the same. And you can certainly build heterogeneous clouds with all of these in it. But it's a hassle to do it. And
the cost possibly. Some of the contracts actually have costs related to getting your data back up.
Well, you have cost of data transfers within them, which may be part of it. If you're running platform as a service, you're more locked in. Of course, if you running on Azure and using their facilities, their scaling facilities, you have to rewrite your code if you want to move it to Google, say.
Ian, you mentioned the bank analogy. Do you not think that that's calls into question your questioning of Carr's thesis? Because surely the last thing we would want to hand over to anybody to look after would be our money, and yet we do. And is that not to do with the service level agreements or the perceived level of risk in handing over our money to this third party to look after? And therefore, if the legal infrastructure
you're quite
is different...
Right. The legal infrastructure allows us to do that, and the banks have to compensate us if they lose their money and so forth. We don't have that legal infrastructure for the cloud.
Of course.
I mean, the whole issue of compliance, service level agreements is, in my view, the biggest issue and problem in cloud computing.
And again, in our project, some of the companies are going out to specific providers and effectively writing a contract to enable them to do that. So rather than going to Amazon, they're going to smaller companies so they can let them manage that contract.
But of course, they don't know if this other company's going to Amazon.
Yeah. Is there any kind of quality assurance? I mean, I know it's a very bland term, but do any of these companies actually really guarantee a service? I mean, when you think of what's happened to nuclear power stations in Japan, the flooding on the East Coast, I mean, if a server centre went down,
when it goes down.
Well, when?
Yeah.
Exactly.
Do they guarantee it? They Amazon offer, I can't remember, 99.99% guarantee, 99.99% availability, and if they can't deliver that, they compensate you. I'm willing to, I've never read their agreement, but I'm willing to bet that it has sort of a force majeure clause in it, so that in the event of something catastrophic happening, it doesn't apply. No, it can't, but that's not really, I mean, that, you have to be careful about major disasters, because, okay, yes, if you lose a data center through a major disaster and your business is in the cloud, that's a problem. But you're probably more likely to have a fire in your own data center if you keep it locally. You've got to trade off risks. It's not that one is risk-free and one is risky. It's just different risks. And you have to make your own judgment as to what are the most important, what are the most significant of these risks. And humans are really bad at doing risk judgments.
And the other thing I was just going to really a comment was, don't tell the government about cloud computing, please. Because if you look at what's happened with, I've just returned from the States, and obviously Obamacare is the issue there. And they've built this huge system, and of course it keeps falling over. Because somebody didn't tell the government that actually if everybody logs in at the same time, the system, even the internet's not capable of
yes, although
managing the traffic.
The British government don't have much of a track record in medical systems either.
Exactly.
You mentioned something about the plan for the cloud simulation and that you predict, costs and stuff like that. Did you use any machine learning techniques to do this prediction?
No. It's just a simple simulation.
Okay. And my other question, I mean, I understand from your talk that it seems you need to be a very big company to be a cloud service provider. Is that true?
I know there are lots and lots of small companies who are cloud service providers, and what they do is they host a particular service, so it's software as a service they're delivering, and then they're buying their computing from a bigger company. They're buying their cloud from typically Amazon. So no, you don't have to be big at all. You don't have to be that big to be a data center provider. I mean, there are IOMart and Flexion are a couple of Scottish companies with data centers in the Edinburgh area, I think. Well, Flexion's in Livingston. I don't know where I think IOMart's in Glasgow. And they're not huge companies. I mean, for a small company, for a startup, going to the cloud is a no-brainer because you don't have to buy servers. So that if you haven't got a company and you want to become a company, your decision is made for you. You go to the cloud from day one.
I just have some concern about security, because when you put your sensitive data, when you put it outside of your infrastructure, there's a permanent problem with security, because even if your data is encrypted, after 10 years, after 20 years, your encryption, this encryption will become very weak for several reasons, like because some cryptographic cryptanalysis
Okay, yeah, right.
gives some result, or just the key becomes weaker.
That's true, yes.
So there's like a permanent problem. Whatever you do, whatever form of encryption you put in your data, if you put it outside, if your data is valuable enough, the guys can keep this data for 10, 20, 30 years and then decrypt it.
Yeah, and why do you think your own data center is secure? It's just the same problem. The probability is that if anyone wanted to penetrate an in-house data center, they probably could do it. There's no reason to think that we have a situation where small to middle-sized companies who are running their own data center are running a secure operation. So it's exactly the same problem. I agree with you about the problem, but it is exactly the same problem. Again, it's about risks. You have a slightly different set of risks when you do it yourself, but they don't go away. The risks, obviously, are if you run your own data center and you're a small company doing some obscure function somewhere, you probably won't come to the attention of hackers. Whereas if you're Amazon or Google, you might be more likely to happen and more likely to be affected. But if you think you're secure, you're wrong.
Unless you go offline.
No, even then you're probably wrong. The Iranians had their uranium centrifuges offline. They weren't connected to the internet and they got penetrated.
Yeah, because they were offline. Talking about connection and internet, but they were not offline because of the USB drive.
That's right. Yeah.
Inside
Yes. There's no such thing as a complete. Or
So
if you have a completely isolated system, it's probably not very useful nowadays.
Yeah.
Sure.
Okay, well, if there's no more questions, can we perhaps thank Ian in the usual way? With a round of applause.